Okay, so we're going to have a look at this big quadratic congruence question. 7x squared plus 15x is congruent to minus 8 mod 93. Now we could turn it into a quadratic by bringing this minus 8 across. So let's just do that to start with. So 7x squared plus 15x minus 8 becomes plus 8 is then congruent to 0 mod 93. So now we're looking a bit more like we're in quadratic form with it equaling 0. But the next problem we've got is this modulus here, 93. It's not a prime number, so we just can't just plug in some numbers and look for the answer that way. We have to break this up into our factors, because if it was a prime number we'd have 0, 1 or 2 solutions. If it's a composite number we could have up to 4 solutions. So we need to factor into that what we can do to make that answer give us 4 solutions. So 93, so we know 93 can be factored out into 31 times 3. Both of those numbers are prime numbers. So that is good news already. So we can now break this congruence question apart into our 2 moduluses. So now we're going to break it into a modulus 31 and a modulus 3, and that will give us our way of getting a solution with up to 4 solutions. So let's break it up now to 7x squared plus 15x plus 8 is congruent to 0 mod 31. And then we can do another one down this side. Let's do the same again. 7x squared plus 15x plus 8 is congruent to 0 mod 3. Now mod 3 being a very small number, very small prime number, that's going to be the easiest place to start with this if you want to break it down a little bit. So mod 3 we can do is can take all these coefficients modulus 3 and it won't affect our congruence at all. So we can quickly see our 7x squared modulus 3 will be the same as x squared modulus 3, because then our coefficient will be 1, and then what we can say is that, let's just write this here quickly, 7 is congruent to 1 mod 3. So if this is the case, 7x squared is congruent to 1x squared mod 3, and obviously we don't need the 1. So I'm going to change this now to an x squared. And then the 15x, so 15 is congruent to 0 mod 3. So this term can disappear. And now let's deal with the 8. So now the 8 is congruent to 2 mod 3. So now we're left with x squared plus 2 equals 0 mod 3. Okay, so now what we can do is we can just transfer things onto the other side. X squared plus 2 we can't really factor into whole numbers. So what we can do now is we can say x squared, so this should be a congruence, is congruent to now minus, so bring the 2 onto the other side, minus 2 mod 3. And then minus 2 mod 3, because we don't want to deal with complex numbers, because x squared and minus 2, that will involve I of some description. So now we've got x squared is congruent to 1 mod 3 by virtue of minus 2 is congruent to 1 mod 3. Basically minus 2 plus 3 is 1. Okay, well now we can easily solve this one now. So we just take the square root on both sides, and then we've got x is congruent to plus or minus 1 mod 3. So that takes care of this side. So just to finish off, to be completely correct, we'll say x is congruent to 1 plus 3k, and x is congruent to minus 1 plus 3k, and then the minus 1 we know we can change that for positive 2, so let's put that into positive 2. So that will be our final part to end this side off. So now we need to deal with the mod 31. So mod 31, that gives us a lot more problems when we're trying to factor this out. Now it can be done, but I'm going to have a look to see if I can factor this first, because if we can factor it, then we're on to a good solution here, an easy way to find the solution. So 7 is a prime number, so we'll have a 7x and we'll have an x, and that'll be congruent to 0 mod 31. Now if we've got an 8 in the coefficient here, for example our c, so this is our a, this is our b, and this is our c. If we've got an 8 here, we need to factor that out. That'll be an 8 and a 1, or a 4 and a 2. Well, we've got a 15 here and a 7. Well, I know 8 plus 7 is 15. So therefore, if we use the 8 and the 1, so if I put the 8 here and the 1 here, so that will then give us an 8x and a 7x, which will give us our 15x. So as those both are positive and this is positive, we're going to need a plus 1. So now, as we did here, without using this algebra, we use factoring algebra, we can now say 7x plus 8 is congruent to 0 mod 31. As it was with quadratics, if you multiply these together, one or both can be 0. So 7x plus 8 is congruent with 0 mod 31. So that is still valid. And then we'll also have, I'm going to write it on here so we can bring them both down together. So we're going to say x plus 1 is congruent to 0 mod 31. Okay, well this one's going to be easy. We'll start with this one first. X is congruent to minus 1 mod 31. So basically I've just subtracted minus 1 from both sides. So now we can just bring that into a positive number. X is congruent to 30 mod 31. So in this form here, I'm just going to write this underneath. So 30 plus 31k. So x is congruent to 30 plus 31k. Now k is any integer. So I'm going to write that here. Okay. Now this one here, a little bit more tricky. So subtract 8 from both sides. So we get 7x is congruent to minus 8 mod 31. Now we need to turn this into a factor of 7 by adding or subtracting 31 each time. Well, I can see that 70 is 62 away from 8. So if I subtract 62, I will get 7x is also congruent to minus 70 mod 31. So that takes care of that. Just a little bit of quick arithmetic in your head there. And then all I'll do now is divide 7 by both sides. So divide by 7, divide by 7. I then get x is congruent to minus 10 mod 31. And then just add 31 on that to give us a positive whole number. 21, and then mod 31. And now I'll just put it into this format, and then we'll go on and use the Chinese remainder theorem. That's going to be our next stage to put the two together. So 21 plus 31k. So that's our solutions, modulus both of the primes. So I'll take this off the board, and now we're just going to work on the Chinese remainder theorem. So once we got to this stage, we're close to getting the answer. So I always start with the small ones first, and then accompany those with the large ones afterwards. So what we do is call this one A, and I'm going to call that x is congruent to 1 plus 3k, and my B, I'm going to call that x is congruent to 2 plus 3k. So write that down on there, A and B, and then call this one C and D. So C will be X is congruent to 30 plus 31k, and my D, X is congruent to 21 plus 31k. So that's my building blocks now to find the answer. So now what I need to do is combine all the A with the C and then with the D, and then the B with the C and then with the D. We can't combine the C and the D together and the A and the B together, as they've come from the same prime modulus for this equation. Right, so A and C first. So let's do A and C. So I have 1 plus 3k, so that takes care of the A part of it. Now for the C part of it, I don't use the k, I use mod 31 instead. So it's congruent to 30 mod 31. So basically that's what that means. 30 plus 31k is modulus 31. Okay, so now subtract 1 from both sides. 3k is congruent to 29 mod 31. So I can now say 3k is congruent to 60. Just add 31 on that, so I've not changed the value at all. And then just divide both sides by 3. K is congruent to 20 mod 31. So now what I need to do now is write this in here now. 1 plus 3k, which is 20, and then plus 31k. And that will give me my correct modulus that I need. So 1 plus 3 times 20, so that's 1 plus 60, and then 31k, that's 93k, which is perfect because that's what we want, modulus 93. So now we've got 61 plus 93k, and that is going to be our first solution. So let's write this up here. X is congruent to 61 plus 93k. So that's our first solution via the Chinese remainder theorem. So I'm going to leave that 1 plus 3k in there because I'm going to use my A again. This time I'm going to combine it with the equation there I've got of D. So 1 plus 3k is congruent to 21 mod 31, just to get me started. So same business as before, subtract 1 from both sides. 3k is congruent to 20 mod 31. Okay, 20 doesn't divide by 3, so I need to keep adding 31 until I can divide by 3. Well, straight away, if I add 31, I get to 51. So 3k is congruent to 51 mod 31, which I now know will divide by 3. So k is congruent to 17 mod 31. So now, as I did in the previous example, 1 plus 3 times my k, which is 17, so that's my 3k. And now what I need is my d, which is 17 plus 21 plus 31k, because I've already taken into consideration this 21 here, because that's what I use that for. So now I've got 1 plus 3 times 17, so that's 1 plus 51. 3 times 31 is 93k. I should always get the 93k because that's our end goal, that's our target. If I get a different number to that, I've gone wrong somewhere. So now I've got another solution. So x is also congruent to 52 plus 93k. So there's two unique solutions. So that's all using my A's. So now I'm going to use the B. So now I'm going to use B and C. So I've got 2 plus 3k. So same as we did before, 30 mod 31. So now I've got 3k is congruent to, well, subtract 2 from both sides. That gives me 28 mod 31. Now I need to keep adding 31 to get a a number that will divide by 3. Well, add 62, that takes me to 90. So 3k is congruent to 90 mod 31. See, this is all valid because these are still valid mod 31. So I'm not really changing any value of the k. So now I get k is now congruent to divide by 3. K is congruent to 30 mod 31. So all I can do now is write this x is congruent to 2 plus 3 times my k, which is 30, and then 21, which I've taken care of. Oh, sorry, I'm on the c. Well, 30, which I've taken care of here, and now it's just 31k. So that gives me a congruence of 2 plus 3 times 30, which is 2 plus 90 plus 93k. So now I've got 92 plus 93k. So that's my third unique solution. So I should now get another unique solution. So B and D. So I've got 2 plus 3k is congruent to 21 modular 31. So that's my B, and that's my D, taking care of the 21 and 31. So as before, 3k is congruent to 21 minus 2, which is 19 mod 31. So now I need to add in 31 to this to get a number that will divide by 3. Well, I'm going to need to add 62. So 3k is congruent to 81 mod 31. So now I can see k is congruent to 27 mod 31. So now I'll write this out again. 2 plus 3 times my 27, so that's my 3k, and then mod 31, so that's plus 31k. Okay, so 2 plus 3 times 27, so that's 2 plus 81 plus 93k. So now I've got x is congruent to 83 plus 93k, and that's my fourth unique solution. So now what should happen if I put, for example, the 61, the 52, the 92 and the 83 into this congruence, it should be correct. So if I go 7 times, for example, if I pick 61 squared plus 15 times 61 is congruent to minus 8 mod 93. Let's just change it. Okay, 61 squared, well, I can do that in my head. 60 times 60 is 3,600, and then add 121 to that, I get 3721. 15 times 61 is also okay. 15 times 60 is 900, then add another 15, so that's 915, and that's congruent to minus 8 mod 93. Okay, let's multiply this one here by 7. Okay, so 7 ones are 7, 7 twos are 14, carry 1, 7 sevens are 49, plus 1 is 50, 7 threes 21, that's 26. So we've got 26047 plus 915 is congruent to minus 8 mod 93. Now let's just take care of these integers here. So 915, that's 26926. Add on 8, 26970. Okay, if I divide this by 93, I should get 0. So, well, 93 times 100 is 9,300. Now I can treble that quite easily. So times that by 3, I get 27900. Now all I need to do is 27900 minus 26970. Well, I can see straight away that the answer to that is 930. So with that, we know mod 93, that is all good. So that's congruent to 0 mod 93. Okay, now I'm going to let you check the 52, the 92 and the 83. Plug them in there, that should be valid. If you don't get the same answer that I get, then put in the comments down below. Check the link in the description below, and there's loads more of these questions that you could have a look at.